Hi, John here. Today we're going to ask ourselves, why do engines need oil? And I'm going to try to answer that question in this video. Now, a lot of you might already know a lot about engines and oil, but if you stick around, you'll probably learn at least one thing in this video. So let's get started. I think the first thing to realize here is that for medium-sized and large-sized engines, you'll have a dedicated lubrication oil sump or a reservoir. And then this lubrication oil will be used or pumped around the engine. For smaller engines, such as a small two-stroke engine, you'll have lubrication oil mixed into the fuel itself. And this is usually sufficient to supply all your lubrication needs for a smaller engine. But let's just assume for the moment that we're looking at medium and large size engines, and that means we have a dedicated lube oil system or lubrication oil system. But what is the oil actually doing and why do we need it? There are four main functions of lubrication oil in an engine. It cools the engine, it cleans the engine, it lubricates, and it protects. So let's have a look at the first function of lubrication oil. When we say it cools, what I actually mean here is it's removing heat from the engine and it's going to expel this heat. Now we need to do this because the engine is incredibly hot. Remember, we've got controlled explosions within the combustion space or within the cylinder liner, and this creates a lot of heat. Now this heat needs to be removed. Some of it or a lot of it will be removed by a jacket water system or cooling water system. Some of it will be expelled directly to air, and the lubrication oil will also pick up some of this heat, and then we're going to cool that lubrication oil back down again to get rid of the heat or to expel it. Now this is all very important because we don't want our oil just getting hotter and hotter and hotter because it'll lose some of its properties. And this means it might not be able to do its job as well as it should. Such as, for example, if it gets too hot, it might become incredibly thin. And that means it's not going to lubricate the engine like it should. So it's quite important the lubrication oil does its job, absorbs some of that heat from the engine. We then release that heat to air, usually through a heat exchanger, or through another medium, maybe to the jacket water system and then eventually to air. And then it returns back to the oil sump and the process continues again. So that's its first function and it's a very important one. The last thing we need is our engine overheating and seizing, which means it's going to stop rotating. The next function of oil is that it cleans. The oil that you'll be putting in your engine nowadays actually contains detergent. And this detergent is used to break up accumulations of sludge and slime that may build up on your pipework or your heat exchangers or on the pump itself. So again, it's quite important because if the pump is damaged or if it's clogged up, then it's not going to circulate as much fluid through the engine as it should, or as much oil through the engine. If your heat exchangers are full of slime, or even if they've got a 0.5mm coat of something on them, on the plates for example, or on the tubes, then your heat transfer capacity is going to be reduced. And again, this means the engine temperature overall is going to increase. So this cleaning aspect is very important. The third function of the oil is that it lubricates. If we have a look at this video here, you can see this 4-stroke engine and you can see a lot of the parts moving up and down, and you can see other items moving round and round. But all of this movement generates friction, and if we had no lubrication, this movement between the metal parts would generate a lot of heat. In order to prevent this, we sort of cover all of the parts in oil, and this reduces the friction, and this also reduces the temperature created when the parts are rubbing together and generally doing their thing. So arguably at this point you could say yes, the oil lubricates, which causes a drop in friction or a reduction in friction, and this again helps keep the engine cool. If you didn't have oil splashing all over the place over the engine components, then the metal is going to rub on metal and you're going to have a lot of erosion and the parts are going to get very hot and then eventually they will seize. So lubricating along with cooling is possibly one of the most important functions of the oil. And the final function of the oil is that it actually helps protect the engine itself. The oil will envelop particles of water and bits of dirt and it will carry these off. Now, The particles themselves will be filtered out by a filter normally. As we can see on the screen here, here's an oil filter we got in the model database. And this oil filter will actually filter out any particles in the oil and make sure the oil stays clean. And the water that is also flushed out by the oil, if there's any in there, normally there'll be a small amount of water. The water itself, if the engine's hot or warm, it will go down to the sump and it will gradually evaporate. Obviously there shouldn't be that much water in the engine oil anyway, otherwise you've got a lot of problems. And another important aspect concerning protecting your engine is that the oil itself actually contains anti-corrosion inhibitors. So this will stop the parts that come into contact with the oil from corroding. Now the anti-corrosion inhibitors and the detergent, that's all in the oil when you buy it, so that's not something that you actually need to worry about. There are other things in the oil, and these are referred to as additives. Now additives can be in the oil for various reasons, but some of the main ones are that they'll be added to the oil to reduce foaming. There'll also be additives to adjust the viscosity of the oil itself. The viscosity is a measurement of how easily the oil flows. So if you have something with a high viscosity, then you have a high resistance to flow. So in other words, you imagine it will actually be quite thick, kind of like honey. If you have something with a low viscosity, then you have a low resistance to flow, and that would be something like water. You know, if you spill a glass of water on a table, it'll go everywhere. It just spreads out quickly. If you spill a glass of honey on the table, it doesn't really go very far at all. So that's viscosity. And with these additives that control viscosity, you have to remember that up to 25% of the oil volume itself may be just from additives. But all of this is in the oil, and when you purchase it, you don't really select your additives or anything like that. So it's not something that you need to worry about on a day-to-day basis. You may see when you go shopping that some people sell additives for oil, and you can add these to your car oil and it will do some amazing wonders, etc. But realistically, if your oil isn't good to start with, you can put as many additives in it as you like and it's still not going to be very good. You may hear people talk about oil grade, and you may hear the words single grade or single viscosity or single weight, or you may hear multi-grade, multi-viscosity, multi-weight. These are different grades of oil. Generally today you won't see single grade oil, you'll only ever see multi-grade oil, and there's a good reason for this. You may not have realized it, but you've most likely seen an oil grade before, or a multi-grade oil before. If we have a look here, we can see 15W-40. That is a multi-grade oil. The 15 refers to how the oil flows, or the characteristics of the oil at a lower temperature. The second number, 40, refers to how the oil flows at a higher temperature. The W signifies that you can use the oil in winter. You can see on the diagram here that 0W-30 at the bottom of the diagram can be used at a much lower temperature than, for example, 20W-50. So the 0 signifies at what temperature the oil can be used. So the lower the number before the W, the more suitable it is for colder climates. The higher the number after the W, the more suitable it is for warmer climates. Larger the gap between the first number before the W and the second number after the W, the more applicable it is, or the more useful the oil is over a wider temperature range. Typically, the oil that you're likely to see will be something like 10W-40 or 15W-40. Although this really does depend on where you live and the type of car you're driving. Sometimes you'll hear the phrase burning oil. Now you're not literally burning oil on top of your engine or anything like that, but the oil will gradually, or the oil reservoir will gradually reduce and you'll have less and less oil. You can actually see this using the oil dipstick. You can dip the engine, and if you come back and dip it 1,000 kilometers later, you should see that the oil's actually gone down. You have less oil than when you started. Now that's essentially what burning oil is. It's where the oil gradually seems to disappear out of your engine. But there is a reason for it. One of the most obvious reasons is that lubrication oil is used between your piston rings and your cylinder liner to lubricate the space between the rings and the liner. However, as the piston moves up and down within the cylinder, some of this oil is left behind as a thin oil film, and this oil is then more or less burnt off by the combustion process. So imagine the piston rings are smeared with oil, they travel up, and then as the piston travels back in the other direction because there's been a controlled explosion within the combustion space, some of that oil is left behind as a thin oil film, and some of that will be more or less combusted and expelled as exhaust gas. If you have a lot of lubrication oil burning in the combustion space, you'll notice that the exhaust gas appears blue. So that's something to keep a lookout for. However, on most cars, you won't notice this because you shouldn't be burning lubrication oil, and you'll just see a clear sort of grey smoke. But even if you're burning just a tiny amount of oil after every combustion stroke, you're still burning oil. Now imagine your engine's doing several thousand RPM. Gradually you're going to burn more and more tiny amounts of oil, and this adds up to what you see on the dipstick, that the oil level gradually reduces. There are other factors involved, such as clearances between all of the parts within your engine. The clearances should always be as tight as possible, especially for things like your exhaust gas valves, because if they're not, more and more oil will find its way into the cylinder liner and more oil will be burnt off. So your clearances are very important. And another thing that is also quite important is your driving style. If you're forever revving the engine and the engine is very hot, the exhaust gas valve is also going to be very hot. And that's also going to make some components in the oil evaporate, which is going to reduce the volume. And that means, again, you've got less oil in your lubrication oil system. There are aging factors with oil. You can't just fill the engine up with oil and then drive for 100,000 kilometers without ever needing to change the oil or replenish it. Some of the biggest aging factors are things such as dirt and dust. These foreign particles or foreign bodies need to be filtered out of the oil using the filter. But even by passing through the system only once, they're still going to have an effect on the engine, particularly concerning erosion. Even if you live in the city or the countryside, this also has an effect on the oil. If you're in the city, you're doing a lot of start and stopping, the engine's never really getting up to a decent temperature, and that means that if there is any humidity or moisture within the oil itself, you're not going to be able to evaporate that off. However, if you were driving down the motorway and the oil is hot, then the water contained within the oil is going to evaporate. Now we've talked about the need to change the oil. This is generally because the oil properties degrade over time, and you'll generally change the oil after a certain amount of kilometers or mileage. You could also change the oil after a certain number of operational hours, and the final factor that people sometimes use is time. Now there's a mixture here of different times or different intervals to change the oil, and some of them might not seem so obvious, but imagine that you have a car for 5 years and in that time it only travels 200 miles. Well, in the manual, maybe it says, okay, after 1,000 miles. However, after 5 years, you should probably really think about having a look at the oil and make sure it's okay. So in most manuals nowadays, you'll get a combination of different variables of when to change the oil. It will say, okay, after 3,000 miles or 5,000 miles, or after 12 months, whichever comes first. It depends on the type of engine, and it also depends on the type of machine you're using the engine with. It could be a car, a bus, a ship, an electrical generator. So it really does depend on what the engine is being used for. So anyway, that was a brief introduction of why we have lubrication oil in an engine and why we need lubrication oil in an engine. If you've got any questions or comments, please let me know. Thanks very much for your time.